Hello everyone, really excited to be here. My name is Fay-Ann Lee. I'm a technical marketing engineer and I'm accompanied by my teammate, Eric Eddy. Eric, do you want to come up here?
So my name is Eric Eddy. I'm a principal TME. I work with Faye. We are here to talk about Cisco Secure Access, brand new product. So go ahead and take it away, Faye.
Okay, yeah, so we're both super excited to share with you some new innovations that we have on a solution that we just launched today, which is called Cisco Secure Access. And so the agenda that I'm going to go through today is I'm going to give you a brief introduction of what Cisco Secure Access is. And then I'm going to start talking about how we're using the solution to reimagine, to deliver an innovative user experience using these innovations that I'm about to share with you. Then I'm going to dive deep into the architecture, and then we'll go into some demos. Okay, so introducing Cisco Secure Access. This is Cisco's new unified SSE solution. All right, so at its core, it has the core components of the Security Services Edge, SSE, right? First, we start off with the Security Web Gateway, right, which provides deep inspection and control of web-based traffic. Then we've got our Cloud Access Security Broker, CASB functions, right, that help you detect malware, alert risky apps, and protect data at rest or in motion. And our firewall as a service capabilities. We all know what a firewall is. It also supports IPS inspection as well. And then Zero Trust Network Access, which is going to be the main focus of what I'm going to be focusing on today in this particular solution. Right? Zero Trust Network Access is all about being able to give least privilege access to a particular resource, thus limiting any kind of lateral movement to protect from vulnerabilities and threats. Before I dive into that, I also want to go ahead and say that, remember, I mentioned that Secure Access is our unified solution. So as the solution itself also contains all of these different capabilities as well. DNS monitoring, multi-mode DLP, Talos threat intelligence from our Talos products. So all of these capabilities, I'm not going to be going into them today, but I just want to highlight that they're part of this solution. This is a single, you get all these capabilities in a single subscription, all managed and configured and monitored from a single dashboard. Okay? And all of these capabilities together provide deep visibility and threat intelligence to block more threats and remediate faster. Okay, so what are we using this solution for? Well, the outcome is, our desired outcome is to provide access, seamless secured access to users anywhere, to applications anywhere as well. So anywhere to anywhere access, securely and seamlessly. And at its core, as I mentioned before, SSE, one of the key core components of SSE is that Zero Trust Network Access. But I want to highlight something, right? And even in the industry today, there's a lot of buzz on providing Zero Trust Network Access using a VPN-less solution. Now, I want people to realize that, do they really want VPN-less? Because, I say that because with ZTNA, there's some architectural limitations. For example, not all applications can work with that. For example, you've got applications that have server-initiated connections, like monitoring and troubleshooting. You can't forget about that. Right? Also, multi-channel applications like SAP and peer-to-peer communications like SIP and any kind of communication software. So these don't lend themselves really well to a ZTNA architecture. And so what this ends up with is provides some confusion to the end user's experience. You know, when they're trying to access a particular application, how are they supposed to know, do I need to be on VPN, or can I get there directly, or what? It just leads to a very confusing and very frustrating experience. And we even have this poll here that says that 49% of the people, you know, employees were frustrated with technology. I don't know, probably the 51% of them were just so frustrated that they didn't even want to bother answering the survey anyway. Okay, so what are we trying to do here with Cisco Secure Access? We want to use our solution to deliver an easy and frictionless experience for our end users, right? So they'll be able to automatically go to any application that they want, regardless of whether that's technically an on-prem application, a SaaS app, or an internet app. They don't even have to know any of that. All they need to do is connect to the network and get to work. And we'll do all the rest of the thinking and all the tech that's required to deliver this experience under the hood. And this is an architectural overview of our secure access solution and how we're going to help deliver this seamless experience. So here on the left, what we have are our users. On the right-hand side here, these are the applications, the resources that our users want to access. And in the middle is basically the secure access solutioning, providing both the security, this is our cloud security infrastructure here, all of the components that I talked about here, DNS, secure web gateway, DLP, CASB, all of firewall, all of those functions that I mentioned before, that's all delivered as part of in our cloud, as part of our service, as well as the fact that we provide options on how to go ahead and onboard our users to our service, as well as onboarding our applications to our service. And I'll start with how we onboard our users. So remote user connectivity here. All right, so I just talked about the different ways of being able to access applications as you know, technologists that we are, right? You've got an option to go ahead and use a VPN connection. You've got an option to go ahead and use a ZTNA, that zero trust, that least privilege access to a particular application. And then we also can have a roaming module here, which can go ahead and redirect just internet-based traffic to web resources. So all of these capabilities here, the user is going to be hidden from the user. And it's hidden from our user because all of these capabilities are rolled into our single client, the secure client. So so then the client is going to be built on different modules. It's going to have a VPN module. It's going to have a ZTNA module, and also have a web roaming module as well. All of that's going to be in there so that under the covers, based on the type of traffic and the resource that the user is going to be accessing, we under the covers can go ahead and negotiate these different connection methods on behalf of the user. So the user doesn't even have to understand any of this. Pretty cool. Now moving on to how we onboard our applications. Okay, so we have two options here. I'm going to start here at the bottom here. This is our traditional IPsec backhaul connection. Right, so we've got our applications perhaps deployed in an on-prem data center. Right, you can go ahead and establish a site-to-site connection with our cloud service, the Secure Access Cloud, and you'll be able to reach those applications. Now, up here is another piece of what we're introducing here today is the application connector. And so what this is a little piece of software, VMware, it could be a cloud instance. You can deploy it in the cloud, right? And it's a little piece of software, an agent, if you will, that you're going to deploy closest to your applications. And what it's going to do is spin up and automatically on its own establish a tunnel connection, DTLS tunnel connection to our cloud. And now what it's going to do is it's going to communicate to the cloud and discover all of the applications that are behind it and act as a proxy resource. So all of to, for incoming traffic. And I'll go into more detail on how that works in just a minute. Okay, so diving into our architecture, I'm going to start first on our client side. All right, so this is our secure client. And as I mentioned before, it's got multiple modules, and this is the intelligence that it has to be able to kind of auto-detect what to do in what situation, right? So this gives the user a transparent experience. And we also have the ability to, provide access that is either fine-grained or coarse-grained, so either, broad access, or we can go ahead and restrict access to the specific user, going to a specific resource, which is what the core principle of ZTNA is. And then the way we are establishing our secured connection to the cloud, we're going to automatically generate a certificate. So we've got a certificate to identify the users, and that certificate, that identity certificate that we generate, that'll be stored in TPM hardware. So that certificate that identity is protected, it's secured, and secured, right? And the way we're going to establish this connection to the cloud with this module, with our client, is we're going to be using some new modern protocols that allow us to support both TCP and UDP based traffic. So we can support all ports and protocols, and with these new modern protocols that I'm about to talk to you about. And this enables us to be able to support both, our own VPN module capabilities, as well as interop with third-party VPN clients as well. And these modern protocols that we're using are MASQUE and QUIC. So let me go into a little bit more detail about MASQUE and QUIC. Okay, so QUIC is basically a UDP-based encrypted transport protocol. It was developed by Google, by people that worked in Google. It was first introduced and used in Chrome, as well as different web applications in 2012. And it's used for HTTP3, in HTTP3, iCloud private relay, SMB over QUIC, and in various areas. And it's basically, this particular protocol was designed to address all of the issues that we have with TLS over TCP today. So it gives you those benefits. Now, we've got that quick transport protocol, and then now we also have MASQUE, which gives you the ability, coupled with MASQUE, gives you the ability to go ahead and encrypt, do an efficient tunneling of this quick traffic inside HTTP v3. Okay, so the combination of these two is going to provide an efficient and a secure transport mechanism that allows for all ports and protocols, TCP, UDP, IP traffic for web, as well as non-web protocols. You're going to be able to send all that traffic through this particular tunnel connection without having to do the traditional VPN method, which is, with VPN, it's a very device-encompassing method that also involves routing table changes. With these, you don't have to do that. So let me dive in a little bit more about the QUIC protocol itself. Okay, so QUIC natively, inherently, as part of what we're designing, right, is that it provides a faster connection establishment. All right, it allows you to change IP addresses without renegotiating, right? So this is very, very, like I said, it was based on UDP. This is totally different than using TLS, which is TCP based, right? TCP, as we all know, is a connection-oriented protocol. UDP is not. So now that we can go ahead and use UDP, there are some benefits to that connectionless protocol, right? Where now we can go ahead and we no longer need to wait for partially delivered packets, because each of the packets are going to be individually encrypted with this QUIC protocol. There's no head of line blocking, so you can go ahead and do stream multiplexing, and it can support multiple interfaces at the same time, so you've got multipath capability there as well. Yes?
How does this compare with DTLS?
DTLS?
Mm.
That's, can you, DTLS, that's a TCP base.
Yeah. Oh.
Sorry.
No, DTLS is UDP, like
Sorry.
QUIC.
Yeah, it's UDP based. So you still have your negotiation of TLS, right? With DTLS, which is a back and forth. With the MASQUE and QUIC, it actually does the TLS negotiation at the first packet. So it's going to establish that connection that much quicker. And of course, as you roam around, the faster you resume, the faster you're getting back to your job. So it's going to allow you to get, and it's embedded right in MASQUE and QUIC, that TLS 1.3. So it allows you to have that connection much quicker. It's still using the UDP, so you're getting, not having to do the three-way handshake, but you're getting the benefit of these new MASQUE and QUIC technologies.
So the performance is roughly the same, but the reconnect's a lot faster.
Yes, it would be. Yes.
Okay.
Yes.
The same as DTLS, but like DTLS connections, like traditional remote access, is in a single place, right? You don't get the multiplexing, right? The multiplexing capabilities really important as you have very diverse networks. You have apps all over the place. Very important to be able to have that multiplexing.
Thank you.
Thanks, Sarah. All right, and then talking about the MASQUE protocol here. So I'm not going to read all of this here, but one thing I want you to remember here with the MASQUE, right? These two things are really important in that when we're trying to decide what to do, right? We're using QUIC, we're going to go use MASQUE, and this is key. The flexibility to support per connection, per app, or per device tunnels. Remember, part of the SSE, core components of SSE, is that zero trust capabilities. Now, with the flexibility of being able to support per connection, per app, or per device, now you're being able to kind of start providing that zero trust, that least privilege access. Okay. And then moving on. And then, of course, native OS support. And so what we have is, these protocols, they're well-known protocols, they're modern protocols now, and now we have our vendors, major vendors today, OS vendors, actually natively supporting these protocols within their operating systems. Okay. Moving on to a little bit more about diving more into about our client and how it actually works. So if we look at this diagram right here, at the very bottom, we can see here, you've got VPN down here. And now using our QUIC and MASQUE protocols, but also what we're doing now is with our client, we're now intercepting traffic at the socket level. So why is this important? Right? So now that we're intersecting traffic at the socket level, right, now we have the ability to control DNS and any kind of application traffic before it gets down further in the stack towards VPN. And then with this, we're not manipulating any routes. There's no route manipulation here. We're not trying to get the goal is not to put with VPN, right? You get a connection you establish that tunnel connection. And ideally what the goal there is to put that user almost like they're actually on that internal network, right? We're not trying to do that here. We're just going to go ahead and intercept that traffic, and we're going to proxy it to a proxy, right? And then we can go ahead and we have the ability to capture the traffic by IP, by IP subnet, FQDN, and FQDN wildcard. So we can go ahead and match traffic based on all of those 4 things, right? And then now, because we're not doing, this is not a VPN connection, we're rerouting all of the traffic and manipulating the routing table. This gives you the ability to have some tunneling capabilities, and then so that we can operate with this ZTNA client has the ability to operate with Cisco VPN as well as third-party VPNs, right? So because there's no routing conflict between, you've got one VPN client and it's routing the traffic this way, and then the other VPN client wants to go ahead and take control of the same routing table. We won't have any of that mess anymore. We're just using the socket to intercept the traffic. So once we've got this traffic and we've now gone ahead and intercepted that traffic, what we need to do is go ahead, and the client needs to go ahead and enroll with our service. And here's how that works. And I'll have a demo of this later on so that you'll be able to see this. And with our client, they're going to go ahead and initially, this is a one-time effort that the user has to do. Okay. And what they're doing is they're rolling it with our service. They just provide their email address. In the back end, we're going to do a lookup saying, okay, this email address, this is the user. They're associated with which particular organization that has these particular, our secure access org services. And then from that point on, in the back end, we're going to go ahead and based on policy, if policy dictates that user, we need to do a second type of authentication to truly verify the user, we can go ahead and do that. We can do that with any kind of SAML 2.0 provider, Duo, Okta, any one of those providers, the IDP of your choice. After authentication, we can go ahead and successfully enroll your device, and then we'll go ahead and generate using Acme. Going ahead and use it through Acme, go ahead and automatically generate a certificate for that client. And that becomes, and remember that certificate is stored in TPM. So truly secure. And then from that point on, anytime a user tries to access a ZTNA protected application, and a little microtunnel is automatically established from that user to the application, specific application. So if the user is accessing 3 applications, now you've got from his client machine 3 microtunnels going to each one of those applications. And since those are little microtunnel, like logically microtunnel connections to the application itself, you've got high security and no threat of any kind of lateral movement at all. So you've got that single streamlined tunnel connection. All right, so that's how you go ahead and establish the connection, the client connection to our service. Now, what about the applications? Okay, so now with our applications, how do we get them connected to our service? As I mentioned before, we have what we call our application connectors. And what these do, as I mentioned before, you go ahead and you would deploy these little agents closest to the resources, your application resources. So in this case here, I've got multiple locations, a data center with applications, a cloud, and even a partner network. And we would deploy these app connectors. And what they're going to do is automatically establish a secure tunnel to the app gateway. What does this give us? Okay, this gives us the ability to go ahead and support overlapping IPs. So what this is doing a proxy connection, kind of like acting as a proxy connection with our app connectors. And so these connectors are aware of the apps that are behind it, and these app connectors, we deploy the app connectors in groups, And basically what we'll tell the service is, hey, I'm the application gateway to these apps, these particular apps. So these 3 application connectors, this app group here, will be responsible for proxying connections to these apps, this one for these, this one for these, right? And since these are just proxied connections, we can go ahead and support overlapping IPs. We could have the same IP address space in each one of these locations. And then there's no, the operations are invisible, so there's no exposed IP address. I'll go over the details of how this works, but there's no over the internet DNS queries. You're not exposing, your internal applications out at all to the internet. There's no breadcrumbs, there's no system leaks, there's just all very protected behind this app connector, and then secured. The connection to our service is secured through this automated tunnel. So looking at the end-to-end workflow here, all right, I'm going to start here on the right-hand side. So here's my applications, and these are my application connectors. The application connectors are going to make that outbound tunnel connection to the application gateway. This is hosted within our Secure Access cloud. And what we're doing in here on the application gateway is going ahead and doing a mapping. Okay, so here's an application, app1.demo.com. It's behind this connector group, this connector group called Application Connector Group A. And we assign it a CGNAT IP. We automatically do this. This is going to be unique IP addresses per customer's organization, right? We're going to assign this IP. So basically the communications inside here, as far as they're concerned, they're just routing packets to a destination of 164.10.1. They're not completely unaware of the actual end application and what its IP address is. Okay. Now, on the left-hand side here, we've got our client established its tunnel connection, and now the user says, hey, I want to go to application1.demo.com in their browser, let's say. So they type that in, our client goes in there, the ZTNA client goes at the socket, intercepts that traffic for application.demo.com, communicates to our proxy, our MASQUE-based proxy. The proxy replies that, oh, this app1 is mapped to this particular IP address. And so that connection from the client is now forwarded to this particular application connector group to ultimately reach the end application. Make sense? Good. All right, so with that, I'm going to show you the first demo that I have. Let me go here. All right, so what I'm going to do here in this demonstration here, I'm going to show you an end-to-end flow. So first of all, this is, I'm an administrator, and I've got an application deployed. In this case, it's deployed in AWS. And I would like to provide ZTNA type access to this application. So I've logged into my Secure Access dashboard. How am I going to go ahead and stitch this connection? So the first thing I'm going to do is create an app connector group. I'll give it a name. Where is this app connector group going to have the nearest location that it needs to connect to reach our services? I can go ahead and based upon the desired throughput that I want, we have this little helper here to kind of guide you. Do I need one application? Now, let me rephrase. most of our we advise our customers to go ahead and deploy these app connectors in pairs for redundancy purposes. But basically, based upon the throughput, when you're trying to go ahead and figure out how many app connectors do I need to deploy, that's determined by the throughput, the desired throughput that you want. So we have this little gauge here of help you. Do I need 1, 2, or 3 app connectors? And then go ahead and save that. So now I've gone ahead and created my connector group. We've automatically generated a provisioning key associated with that group. I'll get into why that's important in a second. But then also, now that I've created this app connector, I got to tell the system what are the apps that are behind this particular application connector, right? So that's what I'm doing here right now, right? I just went through there. I mapped my app that I had deployed in AWS to my new app connector group. Going back here, copying that provisioning key, I go to my AWS instance, and here, what I've done is created a template to go ahead and deploy my app connectors. And I'm going to use that key, that provisioning key that was automatically generated, and associate that with this particular EC2 instance. And that way, that's going to be used as an identifier to which application connector, here's an application connector that's coming online. It just connected to SSE. What is this thing doing? Well, based on its provisioning key, this is associated to the particular app connector group that I created. And the applications that I can reach with that application connector group is that one particular application that I had mapped previously. So I go ahead and launch this instance. Now, if I go back to my dashboard in Secure Access, I can see here, I'm waiting for connector status. I'm waiting for my connectors. Right, I just deployed that EC2 instance. It needs to go ahead and initialize. Once it's initialized, right, it needs to be able to route out to the internet and reach our cloud, and it did just there. Sorry, that was really quick. I'll go back for just a second here. Okay, as you can see, the status connected. It connected from here. So now that we know our connector group is online and stuff, now I'm going to go ahead and transition to the client side. So here's our secure client that we have here. It's been deployed. It's been pre-deployed. It's got its VPN profile. I'm purposely showing here that it's not connected to VPN at the moment. And we also have our ZTNA module as well. Since this is just deployed, it hasn't connected, it hasn't been initialized yet. So I need to go ahead and enroll. This is a one-time effort that the user needs to do. So I go ahead and enroll. As a user, I'm going to go ahead and type in my email address. Connected to my org, my organization says I need to go ahead and do MFA with Duo. So I'll go ahead and do that extra level of security. Continuing enrollment. Remember, we're doing some device registration in the back end, generating that certificate for the client. And now I'm now connected.
So you said that's a one-time user. Is it like one time per boot? Is it one time per I mean, but if they get a certificate, does the certificate expire? When does it expire? Those would be the kind of questions I would have about this one-time enrollment.
So good question, and you're right. The certificate does have to expire for security purposes, right? Right. So right now, it's a 2-week window.
Okay.
Okay, and then it'll automatically.
But it doesn't age out on boot, and
No, it doesn't age out.
It's not impact. Yeah, you already mentioned. I'm pretty sure you mentioned that doesn't age out on an IP change or something.
It doesn't age out,
Okay.
right? Cool. So now with that client, the certificate there, right? So now what the user can do is that app that I deployed out in AWS was a Jira app, and now I'm able to hit that application. Additionally to what I'm trying to prove here is now I've got that ZTNA specific connection. If I try to go to an application that's supposed to be only accessible through VPN, I'm not going to be able to hit that. All right. However, if I were to kick in the VPN connection, I would be able to, in theory, access both applications. And one application would be using that ZTNA approach. The other application is going to, you have access through your traditional VPN connection. And remember, we kind of need this ability to support both in reality for all the type of applications. So with ZTNA, we've got the in MASQUE and QUIC, right? I said that we could support both tunnel, all ports and protocols. We're able to tunnel those connections. But for ZTNA, you've got those server-initiated applications, those particular applications that don't lend itself well to the ZTNA. We have a fallback of VPN with our secure client.
Question about that. The VPN that you're using, I'm assuming, is pretty much the old AnyConnect VPN.
Yes.
So it makes sense to do that now in my thinking because you've already got it. Why not? But does it make sense long-term to simply do essentially something similar to IP relay, like iCloud relay, within a tunnel in QUIC?
Hold that thought.
Okay.
Yeah, so we're going to talk a little bit about mobile ZTNA, right? Mobile operating systems are pretty prolific these days. So let's talk a bit about mobile ZTNA. So if you guys looked at the Apple conference, besides the cool goggles, they did announce some enterprise features. So they have their private relay service, and they're bringing it to the enterprise. So we've partnered with Apple to work with them and use the MASQUE protocol. So this is another reason why we went with MASQUE, was because this is the way the industry is moving. The OSs, not only the mobile OSs, but the actual desktop OSs are also embedding MASQUE right into it. And eventually you should be able to use an MDM to provision that MASQUE proxy inside the OS. So it goes away from all these vendors creating these packet processing to be able to send the packets to the cloud, and now it'll be embedded right in the OS. So when you have any problems, it's ultimately the OS that's having the problems, and not the software or the service that you're using to proxy things. So the enterprise proxy is very similar to that Apple private relay, except you're not using an Apple private relay service. You're using an enterprise relay service. And I believe they're going to support multiple as well. So you can even chain a couple of them in. So say you're a contractor for a couple organizations, you can chain in a couple of these different enterprise relay services. So you can access apps from multiple different companies that are all using this same service. So really cool there. So really great for users because it's really easy to set up. We do have a demo of that. It looks very similar to the client enrollment. The enrollment process is very similar. We wanted to make it very similar. It's all using certificates as well. So really easy to enroll. And then just like ZTNA on the computer, you just turn your device on, it connects automatically. You use your apps just like you would. The user doesn't have to think about it, right? That's the beauty of ZTNA and why users love it, and IT desks love it too, because the user doesn't have to think about it.
So that will cover eventually your tunneled connection as well as your service.
Well, it is a tunnel, just like we saw before. But the only thing you run into issues is those apps that don't support ZTNA type of architecture.
Sorry, I misspoke. It provides the ability to transport an IP tunnel as well as a layer 4 tunnel.
So like an IP-based connection is what you're asking?
So instead of having any connect here
Mm-hmm.
and your ZTNA here,
Mm-hmm.
you can essentially have your IP tunnel encompassed within the ZTNA and just use one solution.
Yeah, that's what we're working towards to centralize around that ZTNA and that private relay service, enterprise relay service to do all connections, make it really easy for users.
Very cool.
So here we have the Apple device. Come on. There we go. Cool. So we have your traditional Apple device here. We have a Tableau app, so we can support web apps as well as a thick app. Right, so this thick app, you're trying to connect to your Tableau, get some data reports. Not possible yet because they haven't enrolled in ZTNA. So we'll zoom back out, and then we have just this app now that will enroll you, and it's very similar to the desktop OS where you just hit the enroll button, and then you put in your email just like you do in most other SaaS apps, and it gets you to the single sign-on provider. We support Apple ID as well, so we're just going to do that Apple ID, Face ID enrollment. And now we're onboarded. So the app is not necessary anymore, and the device will automatically connect to that ZTNA connection. And now we can access our Tableau app and put in the URL again and actually access it now, which we couldn't before. And just like we were talking about the OS before, it's 2 weeks on the certificate. And the user with Apple said that we have to have the button be clicked by the user, so they'll have to say yes to kind of stay in the program, and it'll reissue that certificate to that device and allow them to ZTNA connect in.
So they're not going to. Oh, so they're not going to, just so I know, so like when it comes to a point, if that solution gets deployed, they're not going to like self-restart, right? Like they're going to have to go and actually physically click that. They'll get like an email notification.
I think it's a notification in the OS, right? So we're actually configuring the OS itself. So there's an OS notification. And the app itself right now is kind of like the phase 1. So the second phase of this feature will be MDM configurable.
Okay.
So you won't even need an app like that to do it. So you can just roll it right out.
That's what yeah.
Why would you install an app for one-time use?
Yes.
It's really rubbish.
Yeah.
I just didn't know if there'd be like through like Meraki dashboard or through onboarding, like especially like if some people have an MDM solution like healthcare, someone want to use this, or it gets busy, they don't click it. Can you just go in, set it to just kind of push to all devices and
that's
for them, something like
what
that.
the second phase is really all about. Is so you could push the app now and just tell users click this, and then it's simple.
It seems simple, but even clicking a button, they're not going to be like, this doesn't work.
Yeah, exactly. So
because you didn't click it.
Yeah, so that's why the MDM enrollment is going to be critical for that second phase. So, but yeah, it's really all about providing that connectivity that everyone needs wherever they need it in the simplest way possible.